Okay, so in this video, we're going to be looking at the idea of and versus or. So this is kind of something you've seen before in probability. Um, Usually, if you remember, you'd associate and with multiplication and or with addition. Okay, so we'll be seeing how we can use these terms in the probability that we are doing now. Okay, so the best way I can think of explaining this is through an example. So let's see, example 1 asks, how many different arrangements of letters can we make from the word needed if the word must begin and end with the same letter? Okay, so a few things we need to notice. First of all, we see that the word we were given, needed, has identical letters. We have more than one E, we have more than one D. And we just talked about that in the previous video. So we know how to deal with this. So we just need to take this into account when doing the problem. Then also, since they're not telling us whether the letters may be repeated or not, we are just assuming that they may not be repeated, okay? And then lastly, very important, it says that the word must begin and end with the same letter. And this is actually the condition that's going to illustrate to us the idea of and versus or, okay? So I actually want to go and draw out the 6 spaces because we have a 6-letter word and we want to arrange those letters to form different words. Okay, so nice idea to start out by writing out the spaces. Now I want us to consider the condition that we were given. It says that the word must begin and end with the same letter. Which letters can it begin and end with? We have 3 different letters in this word. We have an N, an E, and a D. This word, or these different spaces can only start and end with an E or a D because we have at least 2 or more E's and D's. We only have one N, so it can't start and end with an N, okay, because we only have one to use. So we can either let this word start with an E and end with an E, or we can let it start and end with a D. And this is where or comes in. We now have 2 different cases. A case where the word will start and end with an E, and one where it will start and end with a D. Okay. So I'm going to write in the word for or. Let's just see it. Okay. So we'll say or. Or. And then we'll have our second case over here. Let's see. 1, 2, 3, 4, 5, 6. Okay. So let's go and fill in these letters as best as we can into the blocks. Okay. So if we look at the first case, let's start by considering putting a D in the front and the back. Okay. And in the second case, we said instead of using a D now, we're going to have an E in the front and the back. Okay, cool. So that leaves us with the remaining letters to fill in the middle. Okay, so we'll have, for the first case, we'll have 3 E's remaining along with an N. Okay, it doesn't matter where we put them. This is just to illustrate kind of how we are building the different letters. Okay, or sorry, the different words using the letters. For the second case, we now have 2 D's left. We have 1 E left, and we have an N left. Okay, awesome. So now, so essentially what we're going to do is, so we have 2 cases, 1 and 2. We'll calculate the probability, the total amount of arrangements for case 1, and the total amount of arrangements for case 2. And since we have this or here, we will simply, to get the total amount of arrangements, we will simply just add these together. Okay, that's essentially all we're doing, is we adding the 2 arrangements, or the total amount of arrangements from both cases together. That's essentially what or is. So let's determine what is the different arrangement possibilities for each case. So in case 1, well, we know that we have a word with identical letters, so we'll have to take that into account. So first of all, we see what is the total amount of arrangements without considering the fact that there are identical letters, if you remember from the previous video. Okay, so let's consider the first case. So you'll see that we have a D in the front and a D in the back. These are fixed values. It doesn't matter whether we put the D's the other way around. Essentially, it's going to give you the same word. It doesn't matter. It's not going to add any more possibilities. So we can write these as 1. It's just one option, okay? And then looking at the leftover spaces in the middle, we have 4 options for the first block, then 3, then 2, then 1, okay? If you're uneasy about what I'm doing now, go back to the previous videos and check it out, fundamental counting principle and working with factorials and things like that. So I'm not going to be explaining everything again. I'm just trying to illustrate the idea of or and in this video. Okay, so what we've done now, so how do we get the total amount of arrangements? Remember, we're starting by considering that there are no identical letters. So we simply have to multiply these values together. Okay, I might as well explain this now. So and basically falls within a case. 2 different cases are separated by or, as you can see over here. But and is what we see here. We have 1 and 4 and 3 and 2 and 1 and 1. That's why we're multiplying. Honestly, I don't even want to discuss and, because I think or is the more important idea. And is multiplying is something we do naturally, something, in probability now. So, but it's important to know where the or comes from, separating the different cases. Okay, so what we've done now is we've calculated the total amount of arrangements of letters we can make by just considering this word to not have any identical letters. So we'll write 4 factorial. Okay, and then we need to divide and we need to compensate for the fact that we do have identical letters. So we have 3 e's and therefore we need to divide by 3 factorial. Okay, and this is going to give us an answer of 4. Okay, cool. So I'm just going to separate this quickly just to show that this is for this guy. Okay. So now we move on to case 2 and we're going to do the exact same thing. So, okay, so what we want to do is just see that the E in the front and the back, once again, fixed values, 1. Now we can look at the center. So this once again is just going to be 4, 3, 2, 1. And we just multiply these values together to get the total amount of arrangements that we can make. Remember, we're considering the total amount of arrangements without thinking about identical letters. Okay, so we do that and we write that at the top, and we have 4 factorial again at the top. And then at the bottom, now we have to compensate for the fact that we do have identical letters. We have 2 D's, so we need to divide by 2 factorial. Okay, and this will give you an answer of 12. Okay, so now what we've done is we've calculated the total amount of arrangements for case 1 and for case 2. Now to get the complete total amount, we simply have to add these values together because they are separated by an or. In other words, your final answer will just be will simply be 4 plus 12, which will give you 16. Okay, and so you can see how or kind of comes into play with these probability questions. Okay, let's look at one last example to make sure that you understand the idea of or. So basically, example 2 asks how many numbers larger than 3,000 and smaller than 4,000 can be made with the numbers 1 to 7 if each number may only be used once. Okay, that's the first part. So let's focus on that. The first part is not going to be about or. That'll come in the second part, which we'll get to. So they're asking for numbers larger than 3,000 and smaller than 4,000. So basically this means that we're going to be working with a 4-digit, something with 4 digits, okay? So the condition they're giving us is the fact that we are with a number larger than 3,000 and smaller than 4,000. So what does this mean for the first space? it means that the only number we can fit into there is going to be, the only number that we can put there is going to be a 3. So of course this 3 is going to be a fixed value, and then it doesn't really matter which numbers we place after that as long as it's not a 3, because we can't reuse 3. So we'll then use the fundamental counting principle to go and figure out how many different numbers can we make larger than 3000 and smaller than 4000. So we'll have, for the first space, well, we only have one fixed value that we can put there. And since we've used one number now, we can we only have 6 remaining for the next space, and then 5, and then 4. And then you use or apply the fundamental counting principle, and you just multiply these values together, and this will give you an answer of 120. Okay, so there are 120 different numbers that we can make larger than 3000 and smaller than 4000 using the given numbers over here. Okay. Now let's look at the second part. This one is a bit more tricky. So it asks how many of these numbers will be odd. Okay, so once again, let's go and draw out our number spaces. So we have 1, 2, 3, 4. Okay, so we know that the first space has to be a 3, because we're still sticking with the fact that we need a number larger than 3000 and smaller than 4000. Okay, that 3 is fixed there. He's not going anywhere. So we can use any of the other numbers for the rest of the spaces except for 3. But now it's telling us, or it's asking us, how many of these numbers will be odd. So now you should ask yourself which one of these remaining 3 spaces, because we have to have a 3 there, so that's staying there. But which one of these remaining 3 spaces is going to determine whether this whole number is going to be odd or even? It's going to be the last space, right? So now we need to think, which numbers can we place here that's going to make this whole number odd? Well, let's look at the numbers we have. If we put a 1 there, it's going to be odd. A 2, it's going to be even, right? A 3, well, we can't put a 3 there because we already put a 3 in the front. It's fixed. So far we have 1, and then we can also put a 5 there to make it odd, and we can put a 7 there to make it odd. Okay. In other words, our choices are between 1, 5, and 7, not 3, remember, because we already put 3 there. So what does this mean? It means that we have, once again, we have 3 cases. Okay, a case where we have 1 at the back, 5 at the back, and 7 at the back. And so OR comes into play. So I'm going to put down the different cases over here. So in case 1, we'll have a 1 at the end. Okay. Or in case 2, let me just draw out the spaces. 1, 2, 3, 4. In case 2, remember this 3 is fixed. And here we'll put a 5. Okay. And then in the final case, in the final case, we're going to use a 7 at the end. Okay. So here we have a 7, and the 3 is still fixed in the front. Okay. And of course, we know that we now need to go and work out the total amount of numbers we can make for each of these cases. And then because of the OR, we will then just add them together, right? Okay, cool. So let's start with the first case. Okay. So we have a 3 and a 1, which are fixed, okay? 1 and 1. And then the remaining 2 spaces, since we've already used up 2 of the numbers, we now only have 5 left. So we'll then have 5 for this space, and then 4 for this space. And then we simply multiply these together, okay? Okay, cool. And 5 times 4 is just going to be 20, okay? Cool. And you'll do the exact same for the following cases as well, for 2 and 3. So once again, we have 3 fixed here, we have 5 fixed there, and so we have 5 left over here and 4 left over there. And we simply have to multiply these together by the fundamental counting principle. Okay, and once again, we'll get 20 for that. And the last case is exactly the same. Here we have 1, so 1 and 5 and 4 and 1, and so this will give us 20 as well. And to get the final answer, or the total amount of numbers that will be odd, we simply have to add these 20s together. Okay, so the final answer, I'm just going to do this quickly. The final answer will then be equal to 60. Okay.